Welcome to a new session on mathematics. Today we will be continuing our discussion on trigonometry. So first, in the last class, or should I say in the first class of trigonometry, we had introduced you the topic. So now in today's session, we will be again doing a brief recap of what we have learned already, and we'll continue solving questions on this chapter, that is Introduction to Trigonometry. Let me reintroduce you this topic. So in trigonometry, we had seen the weightage given to this chapter was 5 marks, of which the concepts that carry a weightage or you should pay more attention to are trigonometric ratios of specific angles. When I say specific angles, I mean 0, 30, 45, 60 and 90 degrees. So yes. And then trigonometric identities. So what are these ratios? What are the ratios of specific angles and what are these identities? We have already learned in our last class, but we will do a quick recap and then get started with solving questions. So let's get started with ratios. So what are trigonometric ratios? Sine A or sine, if I call this angle as sine A, then sine A is called as opposite by hypotenuse. It is totally your choice what you want to call this angle. Usually we call it as theta, or you can call it as A. If I can't call it as B, because when I say B, it becomes this angle. But I'm not referring to that angle as of now. Okay, so sine A is opposite by hypotenuse and cos A would be adjacent by hypotenuse. And what tan A is? The ratio of sine A by cos A. Yeah? So when I take the ratio of these two, what I get is opposite by adjacent. And what about the remaining three trigonometric ratios? Cosecant A is reciprocal of sine A. I can also say sine A is 1 by cosecant A. And what is cos A? Is nothing but reciprocal of secant A. Same way, 1 by tan A is reciprocal of cot A. Correct? So yeah, you just take the reciprocal of that and you will get the trigonometric ratios of cosecant, secant and cot. Okay. Now, trigonometric ratios of specific angles. I had told you, okay, if you remember only the values of sine, right, you can remember the entire table. So what was the trick? Just inverse the sine A, or mirror image of sine A will give you the values of cos. Yeah, and the reciprocal, the ratio of sine and cos will give you tan. So if I divide 0 by 1 is 0, 1 by 2 by root 3 by 2 will give you 1 by 2 by divided by root 3 by 2, right? So that is 2 by root 3. 2 and 2 cancel and you will get 1 by root 3. This is wrong, right? So it is 1 by root 3 and then you get 1 here because it is 1, and then ratio of root 3 by 2 and 1 by 2 will give you root 3. Correct? Yes. See, whenever we tell you something, you should not take it for granted. You should always verify and come to consensus that yes, we both are on the same page. Otherwise, don't take anybody for granted. Not necessary the person who is saying is always right. Verify it, prove it, and then accept their answers, right? And this can happen only when you take up it as a challenge and practice more number of questions. Now coming to identities, you have to remember only 3 identities here. That is sine square theta plus cos square theta is equal to 1, and the other one is 1 plus tan square theta is equal to secant square theta, and finally 1 plus cot square theta is cosecant square theta. With these 3 identities, you can come up with more number of identities by just transposing the other trigonometric function to the other side, and you are voila with the new identity. So if I transpose cos square theta to the other side, it becomes sine square theta is equal to 1 minus cos square theta. Similarly, I can express cos square theta in terms of sine square theta. Same goes with tan and secant. Yeah, same applied to cot and cosecant. Right? So yes, you have to remember only these 3 basic identities and you can come up with new varieties or new variations of these 3 identities. With this knowledge, let's see the ratios. See, as I said there in the beginning of the class itself, these trigonometric ratios. For sine, it is BC by AB. So the side opposite to this angle is called as opposite side, and the side right next to the angle is called the adjacent side, and the biggest side is called as the hypotenuse, right? And the ratio of sine A is given by opposite side by hypotenuse, and cos is given by adjacent by hypotenuse, whereas tan is given as opposite by adjacent side. Clear? And then, as I said, cosecant A is nothing but 1 by sine A. Yes or no? And then secant A is 1 by cos A. And then cot A would be 1 by tan A. Right? So these are the trigonometric ratios that you need to remember. Okay? Then, again, this is the same table. Remember, only the sine functions and mirror image would give you cos, and the ratio of sine and cos would give you tan, and the reciprocal of sine will give you cosecant, reciprocal of cos will give you secant, reciprocal of tan will give you cot. Okay, so you just have to remember one, and yes, you will remember the entire table. Great. So let's move on with the questions now. Fantastic. So here I am again with the challenge question. You think you know the answer? Please do let us know the answer by what? How will I know you know the answer? I could know the answer by only if you can let me know by messaging your answer on this line. If you can send us the answer, right? Yes. Please make me know, let me know that you also know the answer, or if you are confused or you do not know how to solve, you are having an issue solving this, also do let us know on the given link. Okay, you can always send your queries or your solution key to this answer, or an help to how to solve this question, everything on this link. Okay, and we'll help. We are always there to help you out. Okay, so moving on to the next question now. Now, first question of the today's class. Given 15 cot A is equal to 8, find sine A and secant A. So how do we do this? First, let us draw this triangle, right angle triangle. So it is given 15 cot A is equal to 8. Find sine A and secant A. So A means is our angle of interest. So this is the angle. So angle side opposite will be opposite side, and this is adjacent, and this is my hypotenuse. Here what have they given? 15 cot A is equal to 8, or I can say cot A is equal to 8 by 15. And according to trigonometric ratios, what is cot given by? Adjacent side by opposite side, correct? This is cot ratio. Now I can say this is 15 and this is 8, correct? Adjacent side is 8. Yeah, okay. Find sine A and cos A. Now let's do that. So cot A is given. Now I want to find the hypotenuse, right? So how will I get the hypotenuse? Here AC square is equal to AB square plus BC square. So AB is 8 square and BC is 15 square. How did I get this? This is Pythagoras theorem. Always make a habit whenever you are using any ratio or whatever you are trying to use, introduce here, reason it out. What is that you're doing? Okay, so that the examination will be very sure that half mark which the examiners tend to deduct will not deduct here when you are writing everything systematically. So 8 square plus 15 square, right? That is 64 plus 225 under the root. And what is it? that is equal to 289 square root, and square root of 289 is 17. So I know that this side, measure of this side is 17. Okay, now we have to find sine A and cos A. What is sine A? Sine A is opposite by hypotenuse, correct? So opposite is 15 and it is by 17. This is sine A. And what is secant A? Secant A is given by hypotenuse by adjacent. That is basically the reciprocal of cos. So this is equal to 17 by 8. See, here if I have to give you the breakup of how it would be, 1 mark for finding the hypotenuse, 1 mark for sine, and 1 mark for secant. Quite simple and easy marks, right? So we don't want to lose them. Okay, let's move on to the next question. Sine A plus cos A is equal to root 3. Then prove that tan A plus cot A is equal to 1. Here what is given? Sine A plus cos A is equal to root 3. Now we have to find tan plus cot equal to 1. Tan A plus cot A equal to 1. So what we can do here is, first let us remove the square root. So if I want to remove the square root, what should I do? I will square both sides. So square on both sides. So when I square, it will be sine A plus cos A whole square equal to root 3 whole square. Here for root 3, root and square, they cancel out each other and I will get 3 only. Whereas in my LHS, it would be sine square A plus cos square A plus 2 sine A cos A. Remember A plus B identity? A plus B the whole square identity, should I say that? So A plus B the whole square is nothing but A square plus B square plus 2AB. Same thing, right? Here instead of A I have sine A, instead of B I have cos A. Okay, sine square A plus cos square A plus 2 sine A cos A. And we know that sine square A plus cos square A is how much? You are right, it is 1. So 1, okay, 1 plus 2 sine A cos A is equal to 3. Now I will transpose this 1 to the other side. What happens? When 1 plus 1 goes to the other side, it becomes minus 1. So 3 minus 1 is, right, 2. Right? 2 sine A cos A will give you 2. Now this 2 also I will transpose. So what happens? Will it become 0 or should it become 1? See here it was 1 plus 2 sine A cos A. So when I transposed 1 to the other side, it became minus 1. But here 2 is being multiplied. In the previous step, 1 was added. So when 1 is added, when transposed, it becomes minus 1. Here 2 is being multiplied. So when 2 is transposed to the other side, it divides. Because what multiplies on one side, transposed to the other side, it divides. So this would be sine A cos A is equal to 2 by 2. 2 by 2 is nothing but what? 1. So 2 by that is sine A plus cos A. Now let's see. Sine A cos A is equal to 1. Correct? This is what we had got in the last. So instead of this 1, can I not write this as sine square A plus cos square A? Will it matter? Because I know sine square A plus cos square A is 1. So instead of 1, I will write sine square A plus cos square A. Okay, so sine A cos A is equal to sine square A plus cos square A. Now what I will do, I will transpose this to the other side. When I transpose this to the other side, this means sine A cos A. What remains on my LHS? It is 1. So it is 1 is equal to sine square A plus cos, this is cos square A. Cos square A divided by sine A cos A. Okay, so 1 is equal to, I will split this. So when I split, this is in a fractional addition, right? When I split it, what happens? Sine square A by sine A cos A plus cos square A by sine A cos A. Followed? If I take the LCM and want to add, they will come together and I will get back the previous step. So what am I doing? For that step, I am splitting it. So when I split it, this is what I get. Now, observe here, what happens? Square and sine A cancel. If I use loss of exponent, a power m by a power n is a power m minus n, right? You can use the exponents identity here, law, or just 2 and 1. 2 minus 1 is 1. So only sign remains. The same thing goes with cos. Okay, so what do we have here? If I write the RHS first, sin A by cos A plus cos A by sin A equals to 1. What is sin A by cos A? Tan A. What is cos A by sin A? Cot A is equal to 1. What do we need to do next step? Do we even need to do anything now? Let's see what was the question. Voila. That is what we need to prove and we have done it. Right? Fantastic. So moving on to the next question now. Prove that 1 minus sin A by 1 plus sin A is equal to secant A minus tan A the whole square. So how do we do this? Okay, so let's start off. Let's consider the LHS. LHS is what? 1 minus sin A by 1 plus sin A. I'll take that. Now there are two ways of doing it. First, you can start with LHS. That is what I'll be doing it here. Or you can also take the RHS and end up coming to the LHS. You can start with RHS and prove that it is equal to LHS. Or you can start with LHS and prove that it is equal to RHS. Now, what I can do here is, I will not be doing both the methods. I'll do it one. That is starting from LHS and proving equal to RHS. But what you could do from your end is, you can try this at home by starting with RHS. Okay, it is like A minus B the whole square and proving it is equal to LHS. Done? I hope you will all try that. Okay, moving back. I will have considered the LHS. Now I will rationalize this. So 1 minus sin A by 1 plus sin A. So what is the rationalizing factor here? You're right. I have to take the conjugate of the denominator, that is 1 minus sin A by 1 minus sin A. Basically, I'm multiplying and dividing, right, with the opposite sign of the denominator, that is 1 minus sin A. If I have plus, I will take minus. If I have minus, I will take plus. Simple, right? So it becomes 1 minus sin A the whole square, and denominator is in the form of A plus B into A minus B. Here what is A? 1. What is B? Sin A. So A plus B, that is 1 plus sin A into 1 minus sin A is what? A square minus B square. Right? So let's do it. 1 square minus sin square A. Now let's expand the numerator. So 1 or what is 1? 1 square is nothing but 1, right? What is 1 minus sin square A? Remember the identity? Sin square A plus cos square A is equal to 1. So, and when I transpose sin square A to the other side, that is 1 minus sin square A is equal to what? You're right, cos square A. So 1 minus sin A by cos, this is the whole square, is equal to cos square A. Or I can also write this as 1 minus sin A the whole square by cos A the whole square. Correct? Cos square A is nothing but cos A the whole square, right? So I will take this square as common to both numerators and denominator. What do I mean? I will write like this. 1 minus sin A by cos A the whole square. Now again I will split. Got the point what I mean by split here? Yes, I will write it as 1 by cos A minus sin A by cos A, the whole square. I just split this. So what is 1 by cos A? It is secant A. What is sin A by cos A? It is tan A, the whole square. Voila, we have proved. This is RHS and hence proved. Right? You want to check once again? Yes. Correct? Fantastic. Let's see the next question now. Secant theta is equal to x plus 1 by 4x. Okay? Prove that secant theta plus tan theta is equal to 2x or 1 by 2x. Now what do we do this? Secant theta is x plus 1 by 4x. Okay? Now secant theta plus tan theta is equal to 2x or 1 by 2x. Here it can be this or this. So what we will do here is, let secant theta plus tan theta equal to some value, say, should I say x? No, I can't use x because it is here x. Say alpha. Anything you can assume me. Alpha. You could even say A, B, C, D, right? And I will call this as equation 1. Now, we know that identity relating to secant theta, what is it? Secant square theta is equal to what? 1 plus tan square theta. But I will take tan square on the other side. So, secant square theta minus tan square theta is equal to 1, right? Now, this can also be written. This is in the what form? A square minus B square. So, A square minus B square is A plus B into A minus B. So, I can rewrite this as secant theta minus tan theta into secant theta plus tan theta equal to 1, right? Or I can, we know the value of secant theta plus tan theta as what? Alpha. Now let's substitute the value of this as alpha. So alpha into secant theta minus tan theta equal to 1. Okay? Now secant theta minus tan theta is what? Transposing alpha to the other side. What happens? Secant theta minus tan theta would be equal to 1 by alpha. Right? And I will call this as equation 2. Okay? Now, let us add 1 and 2. What happens? Add equations 1 and 2. Let's do it. What happens when I add? I will get plus tan theta and minus tan theta cancels. So I get 2 secant theta. 2 secant theta is equal to x plus 1 by x. Correct? So x plus 1 by x. Or I can say that secant theta is equal to what? See here, secant theta is given as x plus 1 by 4x. Let's substitute that. So 2 into x plus 1 by 4x is equal to x plus 1 by x. Now let's simplify. 2x plus 2 by 4x is equal to x plus 1 by x. Here this is 2x. So that is 2x plus 1 by 2x is equal to x plus 1 by, sorry, this is alpha, right? Alpha. This is alpha. Everywhere it has to be alpha. 1 plus alpha. Now, on comparing, we get, if I compare my LHS and RHS, what is it? 2x is equal to alpha, or alpha is equal to 1 by 2x. Correct? See here, compare it. 2x plus 1 by 2x is equal to alpha plus 1 by alpha. So here, either it can be 2x or it can be 1 by 2x. Therefore, it implies that secant theta plus tan theta is equal to 2x or 1 by 2x. That is what we had to prove, right? See, prove that secant theta is equal to 2x plus 1 by 2x. We started with secant theta and tan theta with an assumption alpha, and we went ahead and proved that that is equal to 2x or 1 by 2x. Clear? Okay, great. Let's move to the next question. Find an acute angle theta when cos theta minus sin theta by cos theta plus sin theta equal to 1 minus root 3 by 1 plus root 3. Now let's do it. What do we have here? Cos theta minus sin theta by cos theta plus sin theta is equal to 1 minus root 3 by 1 plus root 3. Now, what should I do now? Let's divide both LHS, both dividing numerator and denominator by cos theta. So let's write that dividing numerator and see, I cannot just divide only the numerator. If I do that, then it's wrong. If I divide both numerator and denominators, what happens? Okay, the value is balanced. It doesn't impact the value. Okay, so let's do it. So cos theta minus sin theta by cos theta by cos theta plus sin theta by cos theta is equal to 1 minus root 3 by 1 plus root 3. Right? Here again I will be splitting. Why am I splitting? Let's see that. So cos theta by cos theta minus sin theta by cos theta is equal to 1 minus root 3 by 1 plus root 3. I have still my one more denominator here. Right? This is equal to, let's rewrite this. It would be 1 minus root 3 by 1 plus root 3. Let's write here cos theta by cos theta plus sin theta by cos theta. So this is nothing but 1 minus tan theta by 1 plus tan theta is equal to 1 minus root 3 by 1 plus root 3. Now what do we do next? Let's see what do we do next. So this is on comparing. Now compare LHS and RHS. What happens when I compare LHS and RHS? See here, I have 1 minus tan theta. And in the RHS, in the numerator, I have 1 minus root 3. And in denominator, I have 1 plus tan theta. Here on the RHS, I have 1 plus root 3. So as you see, 1, 1, minus, minus, plus, plus. So I can say that on comparing, let me write that step. On comparing LHS and RHS, we get tan theta equal to root 3. Now recall for which angle, yeah, in tan, remember specific angle, in tan of which angle will give you root 3. Think, think, think. So now with that I will get tan theta is equal to, you're right, it is tan 60. Tan 60 is equal to root 3, or I can say theta is equal to 60 degrees. So what was the question here? Find an acute angle theta. We had to find that angle theta. And we did, right? So this is how you have to do it step by step. I hope this is very clear, and we got the value of theta as 60 degrees. Moving on to the next question. The altitude of a triangle ABC, in which angle A is an obtuse angle, has length 10 centimeters. If BD is equal to 10 centimeter and CD is equal to 10 root 3 centimeters, determine angle A. Now, we have to find an angle A. So let's recreate this question in the form of a picture, right? Pictorially represent. So it would look like this. So I have a triangle ABC, in which angle A is an obtuse angle. This angle is an obtuse angle and has a length 10 centimeters. So length is 10 centimeters. If BD is 10 centimeter and CD is 10 root 3, or I can write this as 10 root 3 centimeters, I have to find this angle A. So what I can do, can call this as theta and phi. Because I have two angles, I'll split this triangle into two right angle triangles, right? I'll split this triangle into two triangles. One would be ABD and one would be ADC. So that would be equal to theta plus phi, and that is equal to angle A. Let's do it. Let us write what is the assumption that we have made. As I said, angle A has been split into two angles. One I said theta and one is phi. Let's define that. Let angle BAD is equal to theta and angle CAD is equal to phi. Okay. Therefore, what is tan theta equal to? BD by AD. Why have I taken BD by AD? Why have I taken tan function? It's easy. I can find the values of, because I know the values of AD and BD. And these two sides give me the ratio of tan. Therefore, I've taken that. So, BD by AD is what? 10 by 10, and that is 1. So, for which angle tan theta will it be equal to 1? When is tan of dash some angle equal to 1? When theta is 45 degrees, correct? So this is equal to tan of 45, or therefore I can say theta is equal to 45 degrees. Now this was in triangle BAD. Now let's take the next triangle, that is CAD. In triangle CAD, what happens? I have already said angle CAD is equal to phi. So again, I know the, right? So let's do it. Therefore, tan phi, not theta now. I should say tan phi is equal to DC by AD. That is equal to, DC is 10 root 3 by 10. 10 and 10 cancels, and that remains with root 3. So for which tan phi, or should I say for which angle will it be equal to root 3? Recall tan of dash is equal to root 3. For this you need to remember the specific angles table, right? Yes, so tan phi would be equal to tan 60 degrees, or I can say therefore phi is equal to 60 degrees. Now, if I call this as equation 2 and this as equation 1, angle from 1 and 2, angle A is equal to theta plus phi, and that is equal to 45 plus 60 degrees, right? Angle A will be equal to 105 degrees, and definitely angle A is an obtuse angle. I hope you all would have followed this. All right, let's move on to the next question now. If cosecant theta is equal to 13 by 12, evaluate 2 sin theta minus 3 cos theta by 4 sin theta minus 9 cosecant 9 cos theta. Now here they have given us cosecant theta is equal to 13 by 12, right? If cosecant theta is 13 by 12, what else can we derive information from this? Reciprocal, right? So if this is 13 by 12, then sin theta will be absolutely correct, 12 by 13. Now I know the value of sine, right? Can I not find the value of cos? How? I do not have to draw the right angle triangle and find the hypotenuse and adjacent side and opposite side here. No, I can use the identity. Remember, sin square theta plus cos square theta is 1, right? So if I transpose sin theta to the other side, cos square theta. So let me write it. cos square theta will be equal to 1 minus sin square theta. So this is nothing but 1 minus 12 by 13 square. Okay, so that is, so cos square theta will be equal to 1 minus 144, that is 12 square. And what is 13 square? 169. Take LCM. LCM would be 169 minus 144 by 169. And what is 169 minus 144? Cos square theta would be equal to 25 by 169. So what is cos theta? Cos theta would be square root of 25 by 169, and that is nothing but 5 by 13. Now we know the value of sin theta, we know the value of cos theta. Now simple substitution in the given equation, right? Let's evaluate now. So evaluate, what was the question? 2 sin, I'm rewriting the question. 2 sin theta minus 3 cos theta by, it is 4 sin theta minus 9 cos theta is equal to, sin theta value is 2 into 12 by 13 minus cos theta value is 5 by 13 whole divided by 4 by 12 by 13 minus 9 into 5 by 13. Here LCM is 13. Let's do it. So it would be 12 2s are 24 by 13 minus 15 by 13 whole divided by 12 4s are 48 by 13 minus 5 9s are 40 by 45 by 13. Here denominators are same. So LCM is 13 only. So 13 by 24 minus 15 whole divided by 48 minus 45 by 13. Here observe, 13 and 13 gets cancelled. So what am I left with? Only 24 minus 15 by 48 minus 45. Sorry, 45. So what is it? 24 minus 15 is 9. 48 minus 45 is 3. And 9 divided by 3 is 3. So this is your final answer. Clear? I hope you have got an idea of how to solve these kind of questions. Moving on to the next question. Prove that tan A by 1 plus secant A minus tan A by 1 minus secant A is equal to 2 cosecant A. How do we do this? Now, let's take LHS. Okay, and I'm starting with LHS. So I'm rewriting tan A by 1 plus secant A minus tan A by 1 minus secant A. Now here observe, the denominators are different, right? So what should I do here? Definitely I need to take an LCM. So what would be my LCM? It would be the product of the two denominators. And when I have two numbers, I will use the cross multiplication method. In cross multiplication method, what do? Multiply the denominators and cross multiply, right? Remember, this and denominators both will be multiplied. Let's do it. So 1 minus secant A into tan A minus tan A by into 1 plus secant A whole divided by 1 plus secant A into 1 minus secant A. Now observe the denominators. A plus B into A minus B. What is A plus B into A minus B? A square minus B square. Okay, and let's simplify even the numerators. We'll multiply it. So it would be tan A minus tan A secant A minus tan A minus tan A secant A. I'm multiplying even the sign, minus into plus is minus. So that is why I got minus. And this would be 1 square minus secant square A. Okay, let's simplify. minus tan A secant A is, see here, this tan A secant A. I can add them up. Okay, when I add them up, it becomes minus 2 tan A secant A. But what about tan plus tan A and minus tan A? They cancel out, right? They cancel out. So I would finally get minus 2 tan A secant A by 1 minus secant square A. Now what I can do here is, I have minus in the numerator. So I'll multiply both numerator and denominator with minus 1. So what will it be? So it would become 2 tan A secant A by 1 secant square A minus 1, right? See here, if I multiply, secant square A becomes positive, whereas 1 becomes negative, right? Plus 1 into minus 1 is minus 1. Minus secant square A into minus 1 will become plus secant square A. So yes, so this is what happens. And now, remember the identity? 2 tan A is what identity? Yeah, that is secant square A is equal to 1 plus tan square A, right? So, if I substitute that, I would get 1 plus tan square A minus 1. So, what happens here? Plus 1 minus 1 gone. So, I'll get 2 tan A secant A by tan square A. Okay? Square and tan A cancels. Remember, loss of exponents also I can use here. But I will say they cancel out. So, what remains? 2 secant A by tan A. Now, let's do this. Let's express this as 1 by cos A, right? Secant A is 1 by cos A whole divided by sin A cos A. So, what does this mean? Let's simplify. So, this is 2 by cos A into cos A by sin A. If I bring the denominator up, I have to take the reciprocal. So, when I take reciprocal, cos A gets cancelled. So, I am left with 2 by sin A. And sin A is nothing but 1 by sin A is nothing but cosecant A. So, cosecant A. And this is my RHS. And hence proved. I hope you all would have followed this. Right? Okay, great. Let's move on to the next question. Cos cube theta plus sin cube theta by cos theta plus sin theta plus cos cube theta minus sin cube theta by cos theta minus sin theta is equal to 2. It's very much similar to the previous question. On the same lines, let's get started considering my LHS first. So, LHS is cos cube theta plus sin cube theta by cos theta plus sin theta plus cos cube theta minus sin cube theta by cos theta minus sin theta. Okay, now what? LCM, right? Let's do it. So what happens? What is my LCM here? It is cos theta plus, again, I would say, let me indicate here, cross multiply and multiply for denominators, right? Multiply it. So let's do it. Cos theta minus sin theta into cos cube theta plus sin cube theta by cos theta plus sin theta into cos theta minus sin theta plus, I need space, okay? So what I will do it, I'll write only this here and the other one I'll write it below. Okay, so here plus, it's a continuation. So it would be cos theta plus sin theta into cos cube theta minus sin cube theta by cos theta plus sin theta into cos theta minus sin theta. Okay, now let's see what we do next. That is, now observe here, sorry, Now observe here, let's multiply them, okay? So, and even the denominators, let's do it. So this would be equal to cos, here cos theta, cos cube theta plus sin cube theta can also be written as cos theta plus sin theta, okay? Yeah, that would be easier, right? Then this will become cos power 4 theta if I multiply minus sin power 4 theta. Okay, so instead of doing such a complicated thing, let's simplify the question itself here. So when I simplify the question here, okay, so what happens, let me rewrite this. Cos cube theta plus sin cube theta can be written as cos theta plus sin theta into cos square theta plus sin square theta minus cos theta sin theta. Okay, what have I done? I have just removed the common thing. I have a cube plus b cube identity I have used, right? A cube plus b cube is a plus b into a square plus b square minus ab. The same way I can write cos theta minus sin theta, cos cube theta minus sin cube theta as cos theta minus sin theta. This can be written as cos square theta minus sin square, minus plus sin square theta minus plus cos theta sin theta. Why have I done this? So that I can simplify it here itself. So that is why. So what happens here, observe, cos square theta plus sin square theta is 1, right? So cos square theta plus sin square theta minus cos theta sin theta. See what is happening here. This and this is cancelling, this and this is cancelling. So I'm just left with cos square theta plus sin square theta minus cos theta sin theta in plus cos square theta plus sin square theta plus cos theta sin theta. So I'm rewriting that. So cos square theta plus sin square theta minus cos theta sin theta plus cos square theta plus sin square theta plus cos theta sin theta. Every time just taking the LCM and adding is not the solution, right? Yes. So plus cos theta minus cos theta sin theta gets cancelled and we are left with only cos square theta sin square theta, cos square theta sin square theta. What is that? Identity. Remember 1. This is equal to 1 plus 1. Because cos square theta, always reason out why it is 1. Okay, I know the teachers who are correcting your answer paper are aware of it, but you still stress that even I know this, right? So this is equal to 2 and this is equal to my RHS. Clear? Great. Let's move on to the next question. Prove that 1 plus cos square alpha by cosecant alpha is equal to cosecant alpha. So what am I doing? Let's again take LHS. It is 1 plus cot square alpha by 1 plus cosecant alpha. So what should I do here is I will multiply and divide by 1 minus cosecant alpha. So let me write that. Multiply, I will not touch the 1, okay? Multiply numerator and denominator by 1 minus cosecant alpha. Okay, so now what happens? 1 plus cot square alpha into 1 minus cosecant alpha by 1 plus cosecant alpha into 1 minus cosecant alpha. So this is nothing but what? 1 plus cot square alpha minus into 1 minus cosecant alpha by a plus b into a minus b identity. So this is 1 minus cosecant square alpha. Remember, now I can use the identity. What identity? Cosecant square alpha. Okay, let me write it here. Reason would be cosecant square alpha would be equal to 1 plus cot square alpha. Okay, so I'll be using this, and let me substitute it. 1 plus cot square alpha into 1 minus cosecant alpha by 1 minus 1 plus cot square alpha. Okay, now let's expand this. 1 plus cot square alpha. I'm still keeping the numerator as it is. I'm not multiplying as of now. You will know it soon. 1 minus 1 minus cot square alpha. So 1 minus 1 is 0, right? 1 plus cot square alpha to 1 minus cosecant alpha by minus cot square alpha. So what happens here? Observe. Yeah, cot square alpha gone. Okay, then 1 plus 1 minus cosecant alpha by so that is minus, right? So what I can do is, this is minus here now. Denominator is gone. So that would be 1 minus 1, minus into minus is plus cosecant alpha. So plus 1 minus 1 gone. That is equal to cosecant alpha. This is equal to my RHS. Clear? Now, let's see the next question. 5 cos square 60 degrees plus 4 secant square 30 degrees minus tan square 45 degree by sin square 30 degree plus cos square 30 degree. Simple. Here what is most important is you need to remember all the values of the specific angles. Here it's simple substitution. Let's do it. So 5 cos square. Square, we will square it. So what is cos 60 degrees? 1 by 2, the whole square. Then what is secant 30 degree? That is reciprocal of cos 30. That is 4 into 2 by root 3 whole square minus tan square 45. Tan 45 is 1 square. That is nothing but 1 only. Okay. Now this is equal to sin square 30, or sin 30 is half whole square plus cos 30 is root 3 by 2 whole square. Or I can even say sin square 30 plus cos square 30 directly as 1. But you will all see here, right? Because 30 is same in both for sin 30 and cos 30. So it will still be 1. But even now you can check by substituting the values also, you will end up getting 1. Let's do it. So this will be equal to 5 into 1 by 4 plus 4 into 4 by 3 minus 1 by 1 by 4 plus 3 by 4, because square and square root cancels. So 1 by 4 plus 3 by 4 is what? 4 by 4, right? And what is 4 by 4? Nothing but 1, right? So you end up with only the numerator, that is 5 by 4 plus 16 by 3 minus 1, because denominator has become 1. You saw that? Even sin square 30 plus cos square 30 is also equal to 1. Now let's simplify this. So what do we do? LCM. LCM is 4 and 3. LCM of 4 and 3 is 12. So let's do it. So it would be 15 plus 64 minus 12 by 12. Right? I've taken LCM and I've added up. So that would be 15 plus 64 minus 12. 15 minus 12 is 3. 64 plus 3 is 67 by 12. This is your final answer. I hope this is clear to you all. So with this, I have come to the end of my session today. I hope you all would have followed, and today's class we have continued discussing questions based on introduction to trigonometry, and we have done a brief recap of the topic itself. And I am constantly stressing you, please remember especially the specific angles and the ratios. If you know these two things, you can solve all questions in trigonometry. Everything becomes easy. In the next topic, we will be discussing applications of trigonometry. In that, again, these two concepts are very, very important because we will be using this in this chapter as well. So I'll see you next time with a new topic. Till then, take care and thank you so much.